so this is a special example because in this case we have the omitted variable. We have the variable that would be omitted usually. So what we can do is to run the auxiliary regression. So I'm going to run what happens when I'm going to run the SAT score on the private school dummy and the parental income on the private school dummy. So let's say, suppose I omit the SAT score and I'm running in the short model where I didn't have the group dummies. I omit the SAT score. The effect, delta 1 here is 1.165. So people who have who are going to private school tend to have higher test scores, naturally. It's a pretty large coefficient. Remember, this is table 2-3 that we are trying to compare to. Remember, we have 0.21 without controlling for SAT, and then 0.15 with controlling for SAT. So what we're hoping is that the difference between the two is equal to delta 1, which is 1.165 times the coefficient of the SAT in the regression, and then miraculously it's actually correct. So you can see that you can see the anatomy of the omitted variable bias in this regression. Another thing that you can see from this regression is why the application dummies help. Because we have seen that the SAT score does matter. So why is it that it doesn't matter once we have the application dummy? It's because once we control for the application dummy in the regression, the SAT score, oops, that's not the one I want. In column 3 here, we're controlling for the application dummy in the regression, and you can see that controlling for all the application dummy, the SAT score is not significantly related to the private score dummy. So in the omitted variable regression, in the omitted variable bias formula, what is happening here is not that beta 2 is 0. SAT score does belong in any regression, but delta 1 is 0 once we have all the, once we have all the school dummies, the application dummies. In other words, the application dummies are doing a very good job capturing what should be in there, which is why the omitted variable bias disappears with the application dummies. So, how do we use the omitted variable bias in general? Most of the time we don't have these variables, so otherwise we would include them in the first place. So why is the omitted variable useful? So it's useful because it guides our economic thinking on whether the bias should be important or not. When we're thinking that we're omitting something, is it something that we should worry about or not? Are we omitted variables that are important determinant of the outcome, and are they likely to be correlated with the regressor of interest? I'm going to skip the example, but that's very fun. Like this is, if you read the Well blog, I love the Well blog on the New York Times. I actually do like it. But one of the things that's very funny is that about every other day, there is an article that gives you a nice example of omitted variable bias. So here is a high-fat diet may lead to daytime sleepiness. Might well be true, but this is based on a regression where 1,800 men who had filled out food frequency questionnaire and reported how sleepy they felt during the day. So it turns out people who have more fatty diet also feel sleepy. This is controlling for a bunch of stuff. You could well imagine a number of omitted variable bias here. But there is one every other day, like coffee makes you live longer, whatever. Might well be true, but it's like, this is usually on this, based on these regressions. And that's a big problem with epidemiology in general, that it's just comparing people who are having very different behavior, and maybe there is a lot of omitted variable bias here.